Is the president and co-founder of My 3D Concepts Corporation. 3D2Go is the first 3D printing one-stop shop in the country that offers end-to-end services from scanning to printing, post-production, and color painting. He has a degree in electronics engineering from UP Diliman, where he focused mainly on robotics. He is also the current president of the Philippine Call Center Alliance Incorporated and the CEO of the BPO company Magellan Solutions Outsourcing Incorporated. And to share to us the 3D shops in action, accelerating inclusive innovation in Manila, ladies and gentlemen, a big round of applause please to Mr. Frederick G. Chua.
Okay, so I'm gonna start off first by asking you guys, giving you guys a trivia, right? So I'd like you to pick which one do you think is 3D printed and which one was the scale model building. Is it the one on the left or the one on the right? Which is 3D printed? Who says the one on the left? Left. How about right? Wala, maraming unsure. So I think there's a lot more people that chose the one on the right. So the answer is yes, the one on the right. But I guess the traditional way of doing things is usually assembly, right? You get cardboards, toothpick, acetate, and you assemble them together. But bottom line right now, the technology can be used for, and the quality of the output is actually very similar already, right? So you can replicate things. It's very difficult to distinguish between one from the other, right? The output. Now, I'd like to ask another question. Why do you think that the 3D printing is not yet mainstream? Because right now, as you guys know, it's being used by government, the education sector, the tech sector, engineers. In the consumer side, it's also used by probably hobbyists, right? But it's not yet mainstream. Why do you think? It's not mainstream. And just to give you some perspective, mainstream, when you go mainstream, that's kind of like the holy grail for any industry. Because the critical factor, when you go mainstream, it's used by your father, your mother, your neighbor, and that's where it goes mainstream because the industry will grow exponentially. We haven't achieved that point yet, right? And why is that, right? So, and that's the major challenge right now. If you go back probably during the if you go back probably during the 18th century or the early 19th century, during the time that there was no industrial revolution, mass production, how do you do things? How do you get things? If you wanted a chair or a table, you go to a carpenter. If you wanted let's say a knife or a spoon, you go to a blacksmith or a panday, I guess, or something like that, and have it custom made, right? But because of the advent of mass production, right now, probably, I would think, this is just a guesstimate, but probably 99.9% of everything that you buy right now is a product of mass production. And the purpose of that, the reason for that is because they wanted to lower the cost significantly. So now, the difference here is that you have to be able to, it's a different world, right? It's a different paradigm, right? So when you go to a store, you want to buy a cell phone, for example. What are the choices that you have? You can either buy an iPhone, or a Samsung, or Huawei, or in my case, I'm still buying a BlackBerry phone. But bottom line right now is there's a lot of choices, but it's limited by choices. 3D printing, you're not limited by choices. It's exponential. It's actually, the limit is your imagination. How much you can imagine is really the limit right now. So that's kind of like the difference. What I wanted to talk about is that it's a paradigm shift. So it's a paradigm shift. So in an iceberg, for example, you think that the iceberg is very small, but in fact it's actually big. So what is the paradigm right now? The paradigm is that you're limited by choices. And that's the issue that we have right now in terms of making it mainstream. Because that's the goal. If we go mainstream, the entire industry, Fab Labs, I think, right, I was asking the doctor from NCU a while ago, what's the utilization for Fab Labs right now? And I would think that utilization in Fab Labs is very low. Because I have a friend in Bicol University's Fab Lab. The utilization is very low. A few people having certain projects done, hobby stuff and all that, but it's really not heavily used. I was talking about, is it 80% utilization or 90% utilization. It's not, right? And that's the issue, because it's not yet mainstream. It's only the geeks, the hobbyists, the specialists that use 3D printing. Sorry, I'm kind of like slow, so I have to be a bit quicker. So, now, who amongst you here was a fan of Game of Thrones? Because I was a fan of Game of Thrones up until May, the last season. Now, for those people that are addicted to Game of Thrones, some of them are playing cosplay and stuff like that, and you probably want to imagine yourself as the king of the 7 kingdoms or the queen of the 7 kingdoms. Where do you get something like this? Diba? Probably your best bet would be to go to a toy store, or probably to go online and probably look for sort of like paraphernalia that they sell for Game of Thrones. But it's going to be very difficult. You might be lucky, but it's going to be difficult. How about this? Where do you get something like this? Now, if you have a different fashion sense, you want shades with antlers. Where do you get something like that? I'm sure kahit anong optical shop ang puntahan nyo, wala kayong makikitang something like this. Or instead of a doorknob, you want a hand knob. Diba? Or, for example, diba, sometimes you're walking down the mall, diba? This is applicable mostly for girls, not for guys. Guys, walang pakialam. But for girls, sometimes you see somebody from head to toe, exactly identical yung suot niya sa suot mo. Pati shoes parehas, shirt parehas. Di ba medyo awkward, parang, uy, pareho kaming style. Di ba? And it's not a uniform, ha? Buti sana ko uniform, it's not a uniform. But you can get something like this. Di ba? You can customize something based on your ideas. So, this is the issue. This is the major problem we have to address. Right? Of course, typical customized giveaways, you can do customized bobbleheads, right? Other applications, for example, let's say, magkano ang cellphone cover, yung cellphone casing? It's probably 100 pesos to 500 pesos, cellphone casing. Pero what if, for example, mahilig ka sa horror films? Di ba? Or mahilig ka sa cats? Na gusto mo cat paws? Where do you get something like I'm talking about commoditization, consumerization of products. Because if you talk about applications, of course, the engineering world and all of that, they have a lot of applications. But you need to go mainstream. When it goes mainstream like cell phones, it's huge. Like internet, it's now mainstream. That's why it's huge, because of that fact. So, does anybody know their shoe size? Siyempre, di ba? Di ba? So you go to a shop, you buy your leather shoes or rubber shoes. But does anybody know the dimensions of their face? The length, the distance from your eyes to your nose, to your ears, and why is that applicable? Sometimes, unfortunately, some people are medyo very flat-nosed, right? And if it's flat-nosed, di ba when you buy glasses, it has to be on your nose bridge. It has to be placed on top of your nose bridge. This is a very unique example, but it's applicable, di ba? Now, so you have to have it customized because every individual is different from each other, right? More practical applications. Let's say you know your shoe size, but you know the pattern of how you walk. Because every person has a different way of walking. Some people sakang or flat-footed. Some people, they walk on their toes. Diba? So sometimes mga 1 kilometer pa lang, sobra ka ng pagod. In certain cases, you walk 10 kilometers, baliwala lang sa'yo. So Adidas came up, so this is a heat map of the force that's exerted on your feet. So Adidas came up with, partnered with a company called Carbon 3D, which was explained by Dr. Alvin Cola yesterday as well. This is a known company, Carbon 3D, a multi-billion-dollar company. So one of the challenges of 3D printing right now is that, and I'll talk about Carbon 3D later, but one of the main challenges is the time of print. It takes a long time, right? So anyway, Adidas, the insole, the outer sole of the shoes, everything is customized because the objective is to balance the load of your body on your feet para hindi ka mapagod mabilis. No? So I'm going to talk about this one briefly. 3D scanning, prototyping, modeling, and printing. So I'm not going to talk too much about printing because there's a lot of printing companies here, so they're all going to talk about their printers too. So I'm going to talk about first scanning. What is a scanner anyway, right? It's the conversion from physical form to digital form through a point cloud. So basically a point cloud is points in space that resemble an object itself. So basically when you combine those points, you make a mesh. Then when you convert the mesh into solid objects, it becomes really a solid, the second object. So you have the mesh, which is the first image. Then you have, when you convert it to solid images, it becomes the second one, I forgot what you call it, but then you have to reverse engineer, you have to fix it. Because when you scan an object, there's blind spots, there's dead spots, and you have to reverse engineer to fix things. Once you fix things, you arrive at the finished 3D model, and then when you add texture, that's the fourth image. Okay? So, the way it works is that it projects a pattern in an object, and any distortion in the pattern is taken as points in the point cloud. So that's how it works. So you can scan small objects, you can scan a motorcycle like this. Now imagine, if you were to 3D model a motorcycle like this from scratch, it would probably take you a month or so just to finish something this intricate. But if you had a scan, you could, from 2 months, it might take probably 1 month. So you still need 3D modeling, but scanning really helps a lot in terms of the modeling process. So of course you can scan organic and non-organic objects. And then this is an example of a video that we've done. Oops, sorry. Okay. Sorry. I'm just gonna play this video shortly. Yun. Yep, play. Sige, anyway, this is a picture of a person being scanned, so I'm just going to skip through this. So basically, when we do 3D modeling, so I talked about scanning, the next one is modeling and prototyping. So normally when we talk about modeling, we usually subdivide it, not standard, but we subdivide it based on organic and non-organic modeling. So, but organic, it's monsters, creatures, animals, plants, and stuff like that. Of course, non-organic is based on geometric shapes, circles, spheres, triangle, and all that. Okay, I don't have I have to speed up. So normally you have several different softwares that you use. For organic modeling, it's usually the animation software, Maya, Max, ZBrush, and of course in the engineering world, you're familiar with SolidWorks and AutoCAD. So I'm not going to focus on this because you guys know all of these things already. Thingiverse, PinShape, and of course simpler software tools as well. Subtractive manufacturing and additive manufacturing. I'm just gonna, of course, you guys are familiar with subtractive and additive because subtractive you use CNC machines, of course, and of course additive it's different. Now, one of the things that I wanted to focus on is the differences, right? So why is subtractive manufacturing not ideal? Because it's limited by complexity. You cannot print very complex objects with subtractive manufacturing. Although you know the concepts of the subtractive manufacturing, that's the main advantage of additive manufacturing, is the printing complexity. Because if not, you can just go to a machine shop and have something done, right? So this is one thing. So this is a typical bracket, right? The one that you see on your right is a typical bracket. Using topology optimization, you can actually change the orientation of the object to make it lighter. Because the traditional ways, if I want to make something lighter, I buy a lighter material like titanium or, I don't know, some other aluminum or something like that. But it will also cost you a lot more. How do you maintain the cost by, while making it lighter and not compromising on structural integrity? And that is through topology optimization. So in this case, there's one example of something. And you cannot print something like this using subtractive manufacturing processes. It has to be additive. Another example. The one on the right is 73% lighter. Same material, same function, but 73% lighter. That is one of the advantages. So, I hope I can play this. Oh, can you play? This is Carbon 3D. I was talking about Carbon 3D. The technology of Carbon 3D is called CLIP, right? And yes, finally. Okay, so the video is a 7-minute video. It's sped up 7 times, so it's a 1-minute video. So, you cannot print these objects this fast in other printing technologies. The way it works is basically, instead of printing on a layer-by-layer basis, it prints things by growing it. And the way it works is that with a typical stereolithographic printer or SLA printer, it uses light, laser, or DLP to what do you call this? To fuse photopolymer resins. In this case, you use 2 different variables. You use both lights or lasers to cure, and then you use oxygen to inhibit the curing process. When you use both things simultaneously, you can make it grow, kind of like the process is growing. It's a lot quicker. So imagine po 1 minute. In a typical printer, it will probably take you, I would think at the very least, 50 minutes, an hour, 2 hours. This is a 1.5 by 1.5 by 1.5 inch sphere, right? Ang laki ng difference compared to 7 minutes. And that would change how manufacturing is done. Customized manufacturing processes. It doesn't have to be mass production all the time. So one also advantage of this process of growing things is that when you print, you have to understand that printing on an x-axis, z-axis, and y-axis produces different material properties. You have to be familiar with that. Now when you grow it, wala kang pakialam sa orientation. Whether nakahiga siya or something, it's the same thing, right? So another technology that's new is volumetric printing. Although carbon is already well established, volumetric printing is not. So volumetric printing, for DLP printers that use a projector uses steel frames. When you're printing on a layer by layer, it's always steel frames. This one, it's video. You're projecting something in video format, then you have a resin tank spinning. So when you're printing, you're growing it simultaneously, the entire thing. So this is going to be a very quick, fast technology as well. What does the future hold? Chocolates, of course. You kind of like are familiar with these things. I'm going to speed through this process. Sugar, semiconductor. This was also discussed by Dr. Advincula, which is currently happening right now. In the future, you'll be able to print both conductive and non-conductive materials in one go, and that's a huge advantage. Right now, you print PCB, then you have to put it in a casing. In the future, you print PCB with the circuitry inclusive with the casing in one go, right? It's a huge advantage, both for processing and it's a lot more sturdy. Kasi one piece, right? This is organ printing as well. Right now, we're still not there, but they were able to print the mesh of an organ, but it's still under development. I'm thinking probably another 5 years or so. I don't know, doctor, if it's gonna last another 5 years or 10 years to be able to print organs. There's a company called Organovo, which is kind of like one of the forefront companies that does that in the US. Of course, building. You know, this is already. Actually, these pictures are in China. They're doing this in China. And right now, the 3D printing industry is still, I would consider it still a bit analog. It's still not fully digital. Although the inputs are all digital, the output is still analog. Meaning, kasi in the future, like when you buy monitors right now, you look at 1920 by 1068 or something resolution. Printer should be based on voxels is the alternate of pixels, right? Pixels is 2D, voxels is 3D. Sorry, few minutes. So that's the future. So I'll just play a video that we've done, which is something we're proud of in the prosthetic industry. Sorry, a few minutes. Can you play? So we're doing prosthetics right now. So this is just marketing stuff. But if you fast forward further, I'll show some of the projects that we've done. Yes. These examples of projects that we've done right now, which is we scan the person's leg or arm, and then we reverse engineer and design a prosthetic arm or a leg or a finger or whatever part. Some of them are even functional. We even print functional prosthetic limbs for people. So this is a bit of a CSR for us, corporate social responsibility for us. So fast forward, sorry. Then we do fingers and all that. So next is, sorry. Okay, so another function is in the orthopedic side, right? Orthopedic, that's typically cast mold, right? So nabalian ka ng buto, or your arms, your wrist, your elbow, or something like that, you have it casted. But what can you do with it? Sometimes you wear it for a couple of months. It's itchy, it's uncomfortable. You can't get it wet. You can't take a bath with it. And what can you do? Siguro you can draw on it. That's the only thing you can do. Diba? You have to wear it for a long period of time. But instead of doing that, you can do a cast mold, right? An exoskeleton cast mold. Now, I used to have tendonitis by playing too many cell phone games, unfortunately. So I had a problem with my finger, and the doctor advised me to keep my wrist still. So I actually printed an exoskeleton for myself. So I just basically scanned my wrist, came up with an exoskeleton, made sure that the supports are correct, and then it's functional. It's a lot cooler, it's reusable. If it happens again in the future, I can do it. I can get it wet, no problem. So there's a lot of functional applications to that. So now, functions, prosthetic legs. We've done this, prosthetic legs, fingers as well. We've done, this one's an example of a molded plate that was given to us by a customer. Then they gave us inputs, we finished the model, and we came up with the finished product for them. Right? And then, also in anesthetic tube holder, the current model right now for this anesthetic tube holder is disposable, as what was mentioned to me by the doctor. So we actually came up with they wanted to do something that's reusable, so we came up with that holder for the, whatever that is, right? And this one's bathymetric model. So it's the opposite of topographical model, but under the seafloor. So we came up with some topographical maps for this. Automotive product parts. This is very common applications in the engineering sector. Engine top covers, drone, very typical. Popsicle, kind of like unique, but also we do this for certain customers. So the main objective is really, this one's a good thing. So even aeronautical communication. So the client wanted to enhance the part because it keeps breaking. So we had to redesign it and then enhance the certain part components so that it doesn't become that flexible and doesn't become breakable, right? This is for the ophthalmologist doctor. So she didn't even give us a design. This doctor gave us pictures of things that she saw online, and we actually reverse engineered it and came up with something for the doctor itself, for the retinal imaging adapter. Right? This is our custom design. That's it. So again, as I mentioned a while ago about inclusive innovation, we have to get it to mainstream market. We have to see the function of different people, both if it's either personal or business or practical application. That's what we need to go to. And I think it's awareness. We have to bring it. Everybody knows this, but we have to bring awareness. We're kind of like in the forefront of really bringing awareness of 3D printing to the masses, because that's where it becomes really, really great. That's it. Thank you, guys.